The last question of this paper. The figure below shows a right pyramid standing on a square base. The edge of the base is 4 centimeters. The slanting edges of the pyramid are 7 centimeters as shown in the figure below. So number 17, we are given a pyramid standing on a square base of dimensions 4 centimeters. And then the slanting edges are each 7 centimeters. And the figure is here. Question A says, calculate the total surface area of the pyramid. So if you look at this pyramid, we have the base A, B, C, D, which is a square base of sides 4 centimeters. And then the slanting surfaces are, we have A, B, and V, and then back to A. That is one of the slanting surfaces or planes. And then there's another one on this side, that is V, B, and C, and back to V. That is the second surface. And then the third surface is behind, that is V, D, C, and back to V. And then the last surface is A, D, and V. So those are the surfaces of this pyramid. So for us to get the total surface area, we simply need to get the areas of each of the surfaces, including the base, and then we sum them. So I'm going to begin with the area of the base area. If we look at the base formed by the corners or the edges A, B, C, D, it has dimensions 4 centimeters. So the base is a square, and the area of the base is the same as the area of the square given by length square or side squared. And therefore here we shall have 4 times 4. And then 4 times 4 gives us 16 centimeters squared. So the area of the base alone is 16 centimeters square. Why? Because the base is a square, and the area of a square is obtained by multiplying the side times side. That is one of the areas constituting the total surface area. Now, if we look here, we have slanting surfaces, and ideally, since the base is a square, the slanting surfaces are identical. Let me say that again. Since the base is square, the slanting surfaces are identical. In other words, since there are 4 slanting surfaces, we simply need to get the area of one of the slanting surfaces, and then it is the same area for the other 3 slanting surfaces. So I'm going to extract only one slanting surface, and then we use it for calculations, keeping in mind that it is identical to the rest of the slanting surfaces. So you can choose any slanting surface that you can easily visualize. What I'm going to choose is the surface that is I'm choosing the surface V, B, C, and back to V. And to sketch that, I'm taking this surface here. This is the surface I'm taking. V to B, and then to C, and back to V. That is one of the surfaces. Okay, and let me mark for you all the surfaces. Another surface, another slanting surface is A to V to B, and then back to A. So there is a slanting surface that I've highlighted the boundaries in blue. And then the other slanting surface is going to be V, and then we go to D behind, and then we come to C and back to V. So there is a slanting surface which is V, D, C, and back to V. And now the last slanting surface is V, it goes to A, it goes to D, and then back to V. One thing that you must keep in your mind is these slanting surfaces, they share boundaries. Okay, they share boundaries. That's why you see I've repeated colors, because they share boundaries. Like on a given line, you may see two colors. So those are the surfaces that we have. So from here, I'm going to take this surface V, B, and C. So that surface is like this. It is like that. And then this corner is where I have my B, yes, which is this corner here. And then up I have V for village, and then I have this edge C. So this is where I have C. So if you look clearly, we have B, V, and C. Those are the edges of the surface that I'm taking, which I have marked clearly. And then now the distance or the length BC is 4 centimeters. So here I will put 4 centimeters. And then the slanting surface has a length of 7 centimeters. This length VC. This is the length VC, which is 7 centimeters. So this side here is 7 centimeters. So I have extracted one of the surfaces which has formed a triangle, right? It has formed. If we are to classify it, we see that two sides are equal, right? What type of triangle is that when two sides are equal? Let me see that in the comment section. But that doesn't affect our calculation here. So I have extracted that. Now we need to find the area of this triangle. I remember the area of the triangle A. This is a triangle. Let me name it somewhere here. Let me name it here. So the area of a triangle is given by a half times base times height. And what is the base? Base is 4 centimeters, right? But what is the height? We don't have the height, or we don't know the height yet. So we need to find the height. How do we find the height? Remember, the height is the perpendicular from V to meet the line BC. This is our height. It makes a right angle here with the base. That is our height. So how do we find the height? For us to find the height, we need to apply Pythagoras theorem. And it means we have the length BC, which is 4 centimeters. That means if I mark this point here as O, then from B to O, this side will be 2 centimeters, and then this side becomes 2 centimeters, right? So that there is a total of 4 centimeters on BC. So for us to find the height, we use Pythagoras theorem, and we shall extract something of this sort, half of that triangle. Yes, half of this triangle, where this is our height, this was our side 7 centimeters, but now half of 4 centimeters gives us 2 centimeters. So this side is 2 centimeters. Now from here, this is a right angle triangle. This is a right angle triangle, but the whole of this triangle is not a right angle triangle. Okay, so we form a right angle triangle, and then we apply Pythagoras theorem. And Pythagoras theorem says if you get the squares of two shorter sides and then you add them, they will equal the square of the longer side. In other words, if I get h squared plus 2 squared, they must give me 7 squared. That is Pythagoras theorem. Pythagoras. And therefore, I will have h squared plus 4 equals to 49, right? Press the calculator and simplify the squares. Therefore, my h squared becomes 49 minus 4, I'm getting 45. And therefore here my height, I take the square root on both sides, okay? And therefore my height here becomes, press the calculator, square root of 45 should be 6 point something, 6.71, 6.71. I'm writing to 2 decimal places for now. So this is our height. Our height is 6.71 centimeters. So after getting the height, then we can find the area of this triangle. Remember, our base was 4 centimeters and our height now is 6.71 centimeters. Someone may think 2 centimeters is the base, but that is not true. 2 centimeters would be the base if the original triangle was in this format that we have extracted, but it was not in that format. It was of this format. So the whole BC is the base. And after getting that, then we say our area of this triangle becomes a half times base 4 times our height, which is 6.71 centimeters. Press the calculator. I'm getting 13. I'm getting 13 centimeters. 13.42 centimeters squared. Remember, this is area. 4 is in centimeters. 6.71 is in centimeters. Centimeters times centimeters, it gives us centimeters squared. So that is our area. And remember, this area that we are getting here is the area of one of the surfaces, right? It is the area of one of the identical surfaces, one of the identical slanting surfaces. So now that we know one of the areas, but there are 4, what would be the total area for the slanting surfaces? So total area for slanting surfaces it becomes that 13.42, right, times 4, because there are 4 slanting surfaces. Therefore there are 4 slanting surfaces, as I told you before, V, B, C, and the others. So we multiply the surface area of one surface by 4 to give us for all the 4 surfaces, and I'm getting 53.68 centimeters squared. So this is the total area for the slanting surfaces. But remember, the pyramid has a base, the base A, B, C, D, and the area of the base was 16 centimeters squared, right? So the total surface area becomes the area of the slanting surfaces, the sum of the areas of the slanting surfaces, 53.68 plus the area of the base, 16 centimeters squared, and then you add. I'm getting 69.68 centimeters squared. So this is the total surface area of the given figure, which was a pyramid. That is the total surface area of this pyramid that we are given here. So that is the solution. A quick summary: 1. Get the area of the base, which is a square in this case. Now, if the base is a square, it means the slanting surfaces are identical. So you simply extract one of the slanting surfaces, find its area, and then it is the same area for the other 3 slanting surfaces. So you multiply it by 4. And then you get the total surface area by adding the area of the base to the total area of the slanting surfaces, and that gives you the total area of the figure. That was number 17A, and we shall be going to number 17B and C in the next video. Otherwise, this is Vision Plus, and thank you for being here.